All right, I think we're about to start right now. It's 11:30, so. Hey everybody, how's everybody doing? Good, good. All right, welcome to our presentation on engaging students with customized Linux images for cybersecurity training. My name is Adam Ramirez, and this is my sister.
Maria Ramirez.
And I know it's a long title, but it's definitely worth it. All right, so for today's agenda, it's going to include a quick background about ourselves, and then an overview about what Cyber Patriot is and the training basics for the competition and cyber defense in general. Since our customized VMs are based on our experience with Cyber Patriots, this will provide some background of the use of VMs, and then we'll talk about the benefits of customizing virtual machines and our approach to customizing or themifying the VMs, just to help students get more excited and engage about learning about cybersecurity. And then we'll give a quick demo, which will be demonstrated by Marie, and then we'll open up for some questions at the end. So, my name is Adam Ramirez. I am going to be an incoming freshman at UC Merced. I'm going to be majoring in applied mathematics, concentrating in computer science. I've been in cybersecurity and Cyber Patriots for about 7 years. I actually founded the cybersecurity club at my high school, and I was president for about 3 years. Besides all the computer stuff, I actually do enjoy playing basketball and volleyball. And I published about 3 articles about cybersecurity through Project Cyber. The handle right there for the Instagram is right there. So.
Hi everyone, I'm Maria Ramirez and I'm a rising senior at Bishop Almont High School, and I have been a part of Cyber Patriots for 6 years. This upcoming year will be my 7th year. And I'm now the current president of the cybersecurity club that Adam founded at our school. And I have also published 3 articles as well in cybersecurity, and I've also competed in local Cyber Patriot competitions as well as NCL, which is the National Cyber League. And besides cybersecurity, I like volleyball and photography. I'm actually part of the head yearbook staff at my school. And
So does anybody know what Cyber Patriot is? All right, so we got a few. Well, this is going to be a little refresher, and for those who don't know, well, Cyber Patriot is a nationwide cyber defense competition that's open for high school students and middle school students. Recently, they just added Canada, UK, Australia, and Saudi Arabia. And it helps train students on cybersecurity concepts with hands-on training to inspire them to pursue careers in cybersecurity and also in STEM. It focuses on cyber defense, which means no hacking. So there's a zero tolerance for hacking through Cyber Patriot. And Cyber Patriots also helped both of us understand what VMs are and actually how to use them. So in our script today with customizing VMs, Cyber Patriot definitely contributed a lot to that.
So now I'm going to break down a Cyber Patriot competition to demonstrate some of the key components used in cyber camps that we have participated in the past and that helped inspire us in creating this script. So usually a Cyber Patriot competition is a 6-hour nationwide event where about 5,200 teams consisting of 1 to 5 students per team work on various virtual machines. And points are given by finding these vulnerabilities and securing the system settings and answering some of the forensic questions. But points can also be subtracted if misconfiguration occurs, such as removing an authorized user. And their goal at the end of the competition is to gain 100 points per virtual image. And each of the VMs include a Readme file that describes a scenario, usually about a company with computing policies such as password policies, authorized software, and authorized users and admins. And each of the teams are given 3 VMs that are installed using VMware Player, a Linux system, a Windows desktop, and Windows Server. The main point here is that there are standalone virtual machines and used and must be secured. And here's a graphic of that we have provided that represents the different challenges given at each competition round. But here, our talk today, we're going to be focusing on just the Linux image. But also, in addition to these 3 images, there's also a Cisco packet tracer challenge where students are given a network layout and network-based challenges to configure and routers and switches. Plus, there is also a security network challenge, which is an online-based quiz.
So now we're gonna move on into what is the cyber training through the Linux image. So since we actually are presenting at a Linux conference, I think it's pretty obvious what image we're gonna do a demo on is gonna be Windows. No, I'm just kidding. It's actually gonna be on Linux. We do have a customized Windows image, but we haven't fully automated the whole process yet. So let's continue talking about the Linux image. We did have a couple of goals in mind when creating it. First and foremost, we wanted to create it as close as possible to the Cyber Patriot competition, since this will be used as a training tool. For instance, like typically in the Cyber Patriot competition, they don't really use the latest version of Ubuntu. This year, actually, we participated. They used Ubuntu 18 when actually Ubuntu 22 was the latest version. Second was the use of the VMware player. Although we can use VirtualBox, we actually encountered many problems, such as the hard disk devices. Sometimes we actually have no choice but to use VirtualBox. Another instance of why we only have to use VirtualBox is when we volunteer at some schools, they only have computer labs full of Macs, and through VMware Player, you actually have to pay if you have a Mac. But through Windows, it's actually free. So that's why we had to use VirtualBox. So that's a problem we encountered. Going back to the VMs are zipped up. They're in zipped up files, and we usually install them on lab desktops, similar to the competition and training labs. And lastly, our script sticks to the similar vulnerabilities or challenges provided by the Cyber Patriot competition, as we mentioned before. So the Cyber Patriot cyber defense. So we list some of basic cyber defense vulnerabilities or challenges. So the first one we have is the OS updates. You always have to make sure the OS is up to date. And then the next one is the firewall. Usually during the competition, the firewall is turned off, so we have to make sure it's always turned on. Then as you move on, we got the local security policies, which include password policies and the lockout policies. Then we have the software management. Usually competitors have to check if the software is appropriate for each scenario that's given. And then we have the user account management. Competitors usually have to check if each user is authorized. By that, it means usually you have to add or delete users. Then we have the unauthorized software. Usually Cyber Patriot is big on deleting hacking tools. So Nmap or Wireshark would usually be installed, so we have to delete that or uninstall it. So our approach to customizing a Linux VM, being students ourselves, we kind of understand how students think and learn. So personally for me, if these VMs were actually available, I think they would actually benefit me in the long run. Because if I could relate some of my favorite TV shows with learning, I think that would help me a great ton. So trying to gauge what students are into is a good first step into like addressing this whole situation. After several years in Cyber Patriot and using Linux, we created some of the things we can customize from our learning. I was first inspired by theming a VM when I actually installed one from an online, from online. It was actually themed Walking Dead, so that really inspired me. So I was like, why not just create our own script using it so we can customize it? So once we understood what can be customized, we then generated a list of settings that can be customized. We brainstormed and thought about how can we do that. So we first customized them manually using the GUI and through the command line, but we realized like that was way too inefficient. So after some Google searches and talking to our mentors about this, we decided to challenge ourselves and actually try to automate this whole process. So the CyberCamp training. So during each training session, each student is given a VMware player that is installed in their PC, and we usually give them the zipped up file that they would have to unzip themselves and open up the image. But sometimes we actually walk through it with them just so they can get used to it. We want them to like walk through this whole process and let them learn. So once the VMs are up and running, we usually walk through some exercises using the GUI and the command line. And as we mentioned earlier, we give them challenges that are similar to the competition. So why are we customizing the VM? So it's simple. Kids have the attention span of about 10 seconds until they get bored or distracted. In supporting several camps, we noticed that kids were often distracted as the coaches were presenting their material, and they were not engaged, especially if the material was challenging for them or they weren't able to comprehend it, usually I would see kids bring up games online while the teacher was actually teaching. So I was like, there was a problem there. So I was like, how can we address this? So coming up with customizing VMs, this is like, I think this is one way we can address this situation. But not only does it help the teachers, it could also help the students themselves, because it allows the students to associate things that they're familiar with tasks they're actually learning. So one example is my favorite TV show right now, or currently, is Stranger Things. So having an image themed as Stranger Things, I think that would help me. As I mentioned before, the Walking Dead theme, it actually really caught my attention. So the script can be a great teaching tool for teachers. For example, they can use the script to tailor the VM to the latest movie or TV show that the students are talking about. So the customizations that we made, the most obvious one is the theme background. This is obvious because once the kids start the VM up and they log into the user, they see the wallpaper first, that they see the background. So if they see the background, it's all themed out, I think that would catch their attention right away. And then the next we have the host name. That's just a little additional detail that we added. And the user accounts with passwords, some weak and others complex. This is another big one because when students they get excited when they see the characters that they know actually listed as each user. So it gets them pumped up and talking. So next we have the unauthorized software. As I mentioned before, this is usually like hacking tools. Cyber Patriot, this is more like a Cyber Patriot thing. Just make sure they want to delete the hacking tools. Then you have the scenario, aka the Readme file. This is a really big one because this sets up the whole story, the whole narrative of how the competition is and how it's going to be like. The Readme actually sets up the scenario for the competition. It presents students with company policies, the authorized users, the administrators, and the password. So for the Readme, we use a template for Madlib style where we fill in the blanks with the information for the theme file. And then we have the unauthorized files and the media files. This is just another thing where the students have to check if each game file is appropriate for each scenario. So they would have to delete the media files or the game files. So yeah. So customizing with Python. Why did we choose Python? So we chose Python for a few reasons. First, we wanted to expand our experiences in Python, and it's actually one of the most popular programming languages right now. So we're like, why not we just decide? We actually considered shell scripting, but we were just more comfortable with Python. So as we started with our script, we actually set ourselves a few constraints. First one is being no external modules, a standalone script. Basically, that means we wanted the script to have basic, we didn't want to have any fancy modules. We just wanted default modules. Because when we volunteer at different schools, some of the schools actually block outgoing traffic. So some of the fancy modules will get blocked, so it wouldn't really run well. So we just wanted to keep it default and simple, which brings me to the next point, keeping it simple. We just wanted simple commands just to have one command to change the wallpaper, add users, delete users, and just like that. And then another one that I don't think it's on there, but to run through the command line as root, because if we didn't run through the command line as root, this would be, you're changing the system, so this is something that you would want to run as root. So some features we added, a small list of command line options. This allows people a few options to customize. And then the next one is a big one, is the use of the Uml configurations to define each theme. Does anyone know what Uml stands for? Yeah, what Uml is? Well, Uml is actually a recursive acronym that stands for Uml in a markup language. It's a common text-based, human-readable format for configuration files. The reason why we chose this format was because it's actually popular among many tools such as Ansible and Docker, and plus we just wanted a chance to learn more about it. We'll show an example of the Uml format in the next slides. First, we have the script layout. We have the make theme.py layout. So this is how it's going to be laid out when you run the script. We have the configuration directory. Then as we move down, we have the log directory. Then we have the theme directories. This one's important because it lists all of the themes that are available. So the themes that we chose as an example are Among Us, Avengers, Justice League, and Stranger Things. And then the Stranger Things is the one we're actually going to be using for the demo. And then as you see below here, we have the README template file, the wallpaper image, and the theme configuration, so the Uml format. So right here, this is the command line options. This shows the options that are available in the script. The first one we have the main option is the theme, which actually specifies which theme is going to be applied. Then as we move down, we have the list option. It just lists the supported themes. And then the last two are the standard verbose mode and the help. It displays the help. So yeah, that's simple. Then here's the sample YAML file that I mentioned before. This YAML file actually describes the Stranger Things. As we mentioned earlier, YAML is a text-based human-readable format. So YAML, this is one reason why we chose it, because it's actually like just easier to read. We just have the host name, the theme name. We just have all of it bunched up. Then as we move down, we have all the users. We have the admins, and then we have the regular users with their passwords and usernames. And then we have the software that's installed as we scroll more down. We have Mmap, which is a hacking tool, so students would have to delete that. Then we have Wireshark, Samba, Tree, Audit D. Then we have the media files that are downloaded. This one was just a test one, so they would have to delete it. Then the services that are running, the FTP, SSHD, and Samba. And then the README. This is, as you can see, it has company, services, and software. This is where the Madlet style template comes in. So for the company, we put Hawkins Corporation. That's just that's part of the theme. And then we have the critical services. These are services that have to be running is SSHD and Postfix. And then we have the software, which is just Firefox. So this diagram that we have right here shows the workflow of how the make theme.py actually works, the whole script. So as I mentioned before, we have the theme files of the YAML format. So that's just basically the ones that we showed before, which has Stranger Things, Among Us, DC, Marvel. Then once we run the Python script in the command line, it executes all these commands. So it sets the background wallpaper, it sets the host name, it installs the software, it creates the users, and then it creates the README, and it also creates the admin accounts. So we'll show. So now we're going to move on to the customization demo, which would be demonstrated by Marie. So. So now we're going to give a quick demo of the themed VM, and we're going to walk through the running. We're going to walk it through by running make theme.py script to automatically set the theme up that we're going to have, which is going to be Stranger Things, I believe. So it's going to have to load up a little bit. We have been warned though that giving live demos is risky. But we just have to take on the risk, so hopefully it goes well. We do have a couple backed up VMs though, just in case it all goes wrong.
So now I'm going to be starting with a VM with the base install of Ubuntu and run the script. So as mentioned in the presentation, this is a command line script. So now I'm going to run the command. And as you can see, running the script requires root or administrator privileges using sudo. So sudo allows you to run the commands with these privileges. So now I'm going to run it using sudo. So now let's go over the options that are displayed on the screen. So the first one is the help, which shows obviously the help, as you can see. And then the next is the main one, is the theme option. This specifies the theme that needs to be applied. And then we have the undo option, which undoes the specified theme that you applied. And then the list option, which shows all the available themes. And lastly is the verbose mode. How many of you guys know what verbose means? Well, yeah, it's used for debugging and to show all the different information. So now that we have seen the available options, I'm going to run through the commands. So first, let's run through the list command. So as you can see on the screen, it shows the supported themes. Justice League, Stranger Things, Among Us, and Avengers. But today we're going to be using the Stranger Things. And so now I'm going to type the command to apply the theme. Let me clear it really quick. So as the script is running, the output of the commands is displayed on the terminal. And it's adding all the users. Yeah.
Yeah, there's an error. Well, you can see right here, the background actually changed the wallpaper, so that's like, some of it actually went through, but.
So let's go through the users to see if they added. As you can see, it added all the users from the show. And also we added some non-users so that when the students see this, they're going to have to delete them, and then which will gain points for them. And there would be a Readme file that would show up right there, and that would show like all the company name, all the users, and their passwords, and all the software that needs to be running or installed if they haven't been installed yet. So I'm going to log out and enter in as the default user, which is Hopper. Bear with us. I'm going to zoom in so you guys are able to see what's on the screen. That's much better. So yeah, so you see the wallpaper that was been implemented and the Readme file. So I'm going to open it up and go through all the changes that it made.
Yeah, I don't think we can log into, get the README file because that's, oh, there we go. Oh, there we go.
So as you go through the README, the first thing that you will see is Hawkins Incorporation, which is the company name that we mentioned. And then you would see all the authorized administrators and authorized users, and you obviously see that their passwords are very weak, so the students, they would have to change their passwords to make them more complex. And then at the bottom, at the very bottom, you'll see the critical services, SSHD and Postfix. So these are the softwares that would have to be running in the image. And if not, then they would have to be installed. And I think that's it for the demo.
So here's the, it's now, we're gonna open up for questions now. So also we uploaded the script to my GitHub right there, as you can see, just right there. And then if you want to contact us, here's our emails. So yeah. Yes, in the back. Oh, okay. So for VirtualBox, VirtualBox is free for Macs, but for VMware Player, it costs money for Macs, but for Windows, it's free. So when we usually go to schools, they have computer labs full of Macs. So usually we just run VirtualBox instead. So that's one problem we had. Yeah. 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 Uh-huh. Oh, okay. Then that's that's good to know now. Yes.
Couple of updates on that. VMware Fusion is now available for free for Mac, but as you mentioned on the M1s, it only supports ARM-based images, so you have to install a different version of Ubuntu, and there is no legal way to do Windows on ARM for Macs at this point.
Oh, thank you.
I did have one question on
Yes.
how you initially get that make theme folder into the VM. Like, what's your process? Do you do like shared folders to the VM?
Yeah, I think you share the folders and then it's right there. So then you just type it in. So yeah. Any other questions? Yes.
So I had a question. So like the whole point of like customizing these meters is to engage the students. Is there anything else that you've done, whether it be second feature or to motivate the students engaged with cybersecurity?
Yeah, one way that I try to keep them engaged is usually just talk to them one-on-one or just walk around, make sure they're doing what they're supposed to do. But yeah, that's one way I do.
And yeah, one way I also notice is that the food that's provided, like the pizza, the donuts, it keeps the kids happy. So yeah.
Yes.
Are you currently accepting, like, let's say somebody comes up with a theme they want to help out or contribute to the code, are y'all currently accepting, up, what is it? I can't think right now, but updates to the code commits, thank you, by other people?
Yeah, yeah. You could actually upload your own theme. It's just there's gonna be a different way. You have to let's see, I forgot what it was, but you can yeah, you can make your own theme. Damn. I for.
Do you want to do that through GitHub?
Yeah, through GitHub. So yeah. Any other question? Yeah. Uh-huh.
So it's sometimes really hard to engage students because sometimes they're not that interested.
Yeah.
And like they get bored really easily and have a short attention span. And I found that Kahoots and Candy are a great way
Yeah.
to motivate them.
Yeah.
You ask a question, they answer it, and you just have a bunch of candy right there.
Yeah.
It
Usually
goes
incentive.
really well, especially with like incoming freshmen.
Yeah.
Yeah.
Sometimes you teach middle schoolers and even elementary kids too.
Yeah. That's it. Yes.
So you mentioned you go to other schools to teach them, the kids all about Patriot and whatnot. Are you part of like an organization or you just volunteer your time?
Yeah, I'm just volunteering my time. Well, actually, I did it at my own school. I hosted one for a cyber camp this year, and usually it was just for incoming freshmen, middle schoolers, and also any high schoolers from 9th through 12th grade. Usually we just, hopefully they would get, notice the club, so when it's time for like them to actually join the club, they're ready for Cyber Patriot, because Cyber Patriot's already coming around. So we just want them to get used to it. And then another one is actually, I actually volunteered at my mom's school. She's a teacher. So we went there, we taught 7th and 8th graders, and we just, we went through the VMware images, and so that's basically, it's not through a company, just volunteering my own time, so yeah.
Follow-up question to that, would you be open to volunteer virtually?
Actually, yeah, I'd be up to that. I think I've done that in the past. I not just through cybersecurity, but I've done virtual teaching before through like a program. So yeah, I'm kind of used to it. Yeah.
Are you going to be available mentors on the Cyber Patriot program?
No, I'm not available mentor. I'm just I was a competitor this upcoming, but right now I'm just helping out, volunteering. So yeah. Guess that concludes the presentation. So thank you for coming. This was our first time, so it was a little rough, but yeah. Thank you.
Test. We'll start in a minute, okay? Is it too loud? Is it? Feels kind of loud. Is that better? Is that okay? You're good? Not too loud? Okay. Yeah, it just seems really serious. Hurry up, maybe if I... Ah. How's that? Better? A little better? Yeah, okay, great. All right, let's go. The last slot of the day, except for the keynote, last track slot. It's a pleasure to be with you here today. My name is Bruce Momgen. I normally speak about Postgres, but today I'm going to be speaking about security. I'll explain in a minute why. I work for Enterprise DB, been working there for 16 years. And some of the research that I've done here obviously has been on their dime, so it's kind of fun. I'll explain that in a minute too. If you would like these slides, they are right here. You can download them. There are 58 presentations there and 98 videos of those presentations, including 640 blog entries, mostly about Postgres. But today we're going to be talking about security. So why are we talking about security? Why, as a Postgres core team member, am I talking to you about security? About 6 years ago, let me back up. I work on the CTO team at the company, and my primary job is to work in the community to keep it healthy and so forth. And one of the things that I realized, having done IT for so many years, is that when I was in security discussions, either with customers or when we were talking about it in regards to the database, I kind of understood the security concepts, and I could speak intelligently about the various options, but I realized that I did not have a full understanding of security. And fortunately, because of the type of role that I have, I went to my boss and I said, I'd love to do some research because nobody in the community really has a deep knowledge of security, particularly cryptography. And he said, fine, yeah, go do it. So I bought a bunch of books and I read them and I watched a lot of videos and and I guess 9 months later I had 300 slides. You're going to look at 99 of them today. But there are another 200 also on that website. So the first one talks about really the foundations of cryptography, the mathematics behind it, elliptic curves, hashes, private keys, primes, and so forth. The second one primarily talks about SSL, or in more modern parlance, TLS. how TLS works, how you can set up certificates, how you can basically configure TLS, how it works, how it does the handshake, and so forth. The third one is about configuring hardware security devices. That covers things like the Yubikey, if you're familiar with that, and a couple other devices. And this one, which is the one that the organizers presented, is unusually the last one, but the most applicable perhaps, which talks about how to use cryptographic hardware to secure applications. Now, this might be a new topic to some of you, but effectively, cryptographic hardware is a specialized device that performs some cryptographic function. And normally, the value of that cryptographic device is its ability to be detached from a client terminal, from a server, and when it's detached, it takes its security capabilities with it. So you can imagine somebody steals the server, somebody steals a machine. If the cryptographic device is not attached, they can't do a whole lot with it if the system is properly configured. And that's what I'm going to be talking about today. Okay, so I'm not going to be talking about the mathematics of it. I'm not going to be really talking about TLS or how to configure it. Yes, I have those slides. They are on that website. I believe there are videos of all these as well. So if you want to really just make sure you're sitting down for that, because it's a difficult. I actually go back to those once in a while when I forget a small detail, maybe of how TLS works or how the secrets exchange. I'll be like, oh yeah, it's Diffie-Hellman, and oh yeah, you know, we have to create the certificates this way, and the private key goes here, and so forth. So, any questions before I start? Okay. Yep, we're glad to answer questions as we go. Okay. So let's take a look. So we're going to basically talk about how we connect cryptographic hardware and these these application types. So OpenSSH, which is an SSH client, Open Pgp, which is used for encryption as well as email, and that type of thing, if you're familiar with that. We're going to talk about PIV devices, which you may not have heard of before, but I've become somewhat adept at those. 5, we're going to talk about my favorite use, Postgres. All right. And then in 6, we're going to talk a little bit about database encryption scope and a little more database specific stuff. And then finally, private key storage options. Okay. Okay. So let's talk about OpenSSH. Now, as you know, OpenSSH is, hopefully you would know, when you type SSH at a Linux terminal, you're getting OpenSSH. There's really two, just be aware there's two open things, and I've always gotten this confused. OpenSSH is the shell command, right? OpenSSL is the TLS library. Okay, so just if you hear OpenSS and you think, oh, that's, you know, that last letter is pretty important. Yeah, I know H and L are pretty close in the alphabet, so they look kind of the same, and they got the big, but they're really performing a different service. So this is OpenSSH. Okay, and what I have done here is to create a host that effectively does not allow passwords. So it requires a certificate to connect to SSH. That's the way I do all of my SSH, frankly. I do recommend it for most use cases, and there's two main reasons for that. One, it's fairly hard to steal the private key of a SSH pair because the key is never passed across the network in the same way that a password is. Okay? And then secondly, the key is so complex that no matter how many times somebody guesses, they're never going to be able to construct in any reasonable amount of time, centuries, right? Construct a version, a packet that actually matches. Okay? So again, two reasons. One, hard to steal the private key because, of course, it doesn't get passed. It gets mixed with other things. And then secondly, it's very hard to brute force it. That's the term we use. Okay. So again, if you are still using passwords, whether it's with Postgres or with SSH, you might want to be moving into something like an SSH, a certificate case. Any questions about that? Because that's kind of a fundamental thing, at least for me. And I learned, again, I used to talk about it and I sort of knew what I was saying, but I didn't really. Now I can really speak in the right terms. I can talk about the private key versus certificate. For example, certificates are publicly available. I can see public certificates for websites all day if I want to. It's the private key that's actually the secret that you have to prove you own the certificate. That's really what you're doing when you're logging in. So again, I'm not talking. I have and this is somewhat disappointing. The configuration of this actually is in the previous slide deck, right? So I submitted all 4 slide decks. We've chosen this one. I think it's the right one because I think it's going to be most applicable. But again, if you want to know how to configure SSH with hardware security devices, look at the previous deck. It's called, instead of being called Cruising Cryptographic Hardware to Secure Applications, it's called Cryptographic Hardware Configuration, and it talks about how to configure all these things. Okay, so because I am using a Yubikey in this case, and you can see that right here. I don't work for Yubikey. I don't have any of their stock. It's just a cheap device that is fairly highly functional. It could be an RSA device. It could be any of these. Does anyone use any of these devices regularly? Yes? Okay. What manufacturers? That would be good to help to know. Gemalto. Oh yeah, that's an old, they've been around a long time. Yeah. They've been around a long time. Other people? Okay. Yubikey, other ones? Yeah? Nitro. Oh, is that also Yubikey? No. Nitro is a separate company. German. Oh, I have heard of them. Now that you're, yeah. Anyone else? Is that the big ones? Okay. Anyway, yeah, it's kind of interesting. I actually have one. I actually have one right here. If you're really, really super curious, you might laugh, but maybe I don't. Oh, I think I lost. Yeah, exactly. You totally got me. Yeah, I was carrying it in here forever. And I might have just stopped carrying it because I was like, oh, why am I carrying this thing around? No, I guess I don't have it. Yubikey, it comes in different formats. So you can get it in, yeah, exactly. You can get it in a little size that's effectively the size of a USB ending. Right, just that little square, the USB part that you go is literally that big, and then they have more of a like a memory stick size that you can put in. They have a USB-C version that you can stick in your phone. So there's different formats. Again, Gemalto's good, Nitro's good. They're all really good stuff. But here I'm using Yubikey. So basically, what I have to do here is I have to use a tool. I'm using a tool to show you the Yubikey. It's called PKCS15 tool. Again, we covered that in the previous slide deck. But it's basically reading the SSH key out and it's dumping it into a file. Now, remember, this is the public key, not the private key. That's actually the hugest advantage to SSH these devices. You cannot get the private key out. Right? People sometimes ask me, well, why don't I just put the private key on a USB stick? And use that. And you can, but keep in mind that when that USB stick is inserted, that private key is readable by the operating system. One of the cool things about these cryptographic devices, and I think the most valuable, is that the key literally cannot come off of the device. If you want a backup of that key, you basically create the key off of the outside of the device, make a backup, and then store the public and private key in the device. I actually have an example of that in my previous slide deck. Okay. So basically, it's asking for a PIN. These all require some kind of PIN, so you have to type it in, or you can manually do it if you want. And that actually is my key, my RSSH, my RSA key right there. That's the public part. Now there's some dots here. It's much longer, but you get the idea. And then what I can actually do is I can put the key into my OpenSSH authorized keys file. If you're familiar, there's a bunch of ways of seeing the public key. One way is that one long string. It starts with SSH RSA and then a big string. You just concatenate it onto the end. And that's actually what I'm doing right here, concatenating, right? And then what's really cool is I can then do an SSH, okay, and I specify the OpenSC library, and I can actually connect without a password, because what I've done is I've extracted the public. Remember, I said you can't pull the private key off of the Yubikey, but you can pull the public key. So I pulled the public key off, I put it in my authorized keys, and then I can actually SSH into my system with no password. But what is happening here is because I've specified the OpenSC library, it's going to reach into the Yubikey. It's going to pass something in, get it signed or encrypted by the private key to prove I am who I am, send it to the server, and then I've actually logged in, and it says I've logged in, and now I'm a new user. Okay, so that's an example. I just wanted to give you the flow of what this is going to look like. Again, there's a lot of presentations before this to get here, but the idea is, and you may not need to know the other presentations. The point is that what I'm doing is I'm using the hardware device to do a login without requiring a password at all. Okay, when I mean, and it's very similar on my phone. Now I don't have a Yubikey on my phone, but it's a similar issue. If I start an SSH client here, there's a private key on my phone, and that's how I'm logging in. I'm not logging in with any kind of password. Okay. Another thing you can do is to effectively, instead of basically, you can basically add the PCS 11 provider, so you do not need to use the -I. Do you remember I used the capital I? So again, if you don't want to use that for every SSH connection, there is a file called SSH config in your home directory. And if you add the lines I'm specifying here in the middle, then you can see at the bottom I didn't need the I, because it knows that there's a PKCS 11 provider called OpenSC there. Okay, so that's kind of a way of avoiding that. Now I'm basically saying I'm always going to be able to use that. Okay, and again, if you're curious about more details, right here at the bottom we have a URL that might help you. Again, you might want to download these slides and just click on the URL, and it'll take you right to that. Now, you can just spend hours in this thing just clicking on links and reading details. But again, if you're curious how I got there and what things, and again, this slide deck's also online, so it's easier just download it and click as much as you want. Okay. Another way to do this, if you're, as I said, I know you mentioned before that each time it's asking for a PIN. Do you see this asking for a PIN here at the bottom? So there is something called SSH Agent. SSH Agent is part of the standard tools that you typically get with SSH. And what it allows you to do is to basically cache the PIN for a specified amount of time. So then repeated uses of SSH is not going to require you to keep typing the PIN in. Effectively, what we do here is we're starting SSH Agent right here. And then we're basically using the passphrase. And then if I do that, you can see the next one, it doesn't require it. Okay, so it kind of like, it remembered that I needed it. And again, we have two URLs here at the bottom for details about that, how I got here. Okay. There's another way of doing this. I actually create a script for controlling SSH Agent because I wanted to auto start. Again, I'm not going to go through the script. There's a lot of slides here that I'm not going to go through, but feel free to use the script, copy paste from the PDF. You should have no trouble doing that. And basically all it does is it basically starts SSH Agent when you log in, and then it keeps it running, basically. Okay. And again, there's other tools out there that do something similar. Okay. Here's how you install SSH Agent D, and then you can basically run it. And there's a bunch of other scripts that do similar things at that URL right there. Okay. Here's how you would start it in your login, and then you can see that effectively it works fine. So here we start the agent, and it basically is requiring it the first time, and then after that it doesn't require it. Okay. Okay, any questions about OpenSSH? I was just trying to give you the framework of how that would be useful. And again, the big use of this is if you take your hardware token out of that computer, nobody can log in from that computer, right? That's really the value of these devices. Okay. Second one, Open Pgp. This used to be, I don't know, I used to see a lot of this back in the 90s and early 2000s. I don't see this as much. Maybe it's more standard. Maybe I'm less geeky. I don't know. But it's basically a library that allows you to do a whole bunch of security related things. I think Phil Zimmerman is the author of this, and he's been around forever. Also, if you've heard of Open Gpg, which is kind of the opposite of PGP and Gpg, it's the same thing. It does file encryption. It does signing using your key. It also does OpenSSH as well as PAM. You can even use it for git commit signing. I actually do use a Yubikey for git commit signing, but no, actually, I'm sorry. I use it for git pulling from an authorized host. I don't use it for signing. So eventually we may get there, but right now that's what I use it for. You can even use it for Postgres encryption, and again, there's a pretty good PDF there. Okay. So again, Open Pgp or PGP or Gpg contained a single active subkey used for signing. So again, it's designed around email, but now it actually has become more like a PIV device. How many people know what a PIV device is here? Okay, we got one. So I'm just going to give you the background, and I'm going to show you PIV device here, and also there's a huge amount of PIV in my previous talk. A PIV device is basically a credit card-like device that's used typically by companies and absolutely by the U.S. government. And it's very similar to a credit card that has a chip on it. You're familiar with the chips. You know, you have a credit card and it's got the chip on it at the top, right? Well, that chip, I know we've gotten them in the past couple of years, but that chip actually can be a hardware encryption device. And that's exactly what a PIV device is. And it actually has 4 different roles. One is signing, one is encryption, one is authentication, and then there's a 4th one, which is kind of weird. But Open Pgp actually has those slots now, so you can have different keys for different purposes. Instead of having, because imagine in key rotation, you might want to rotate your authentication key every year, but you may never want to rotate your signing key, for example, because then you couldn't validate the signatures anymore. So again, you now have the idea of rotating. Again, expiration and revocation are important, and it's very similar to how TLS works. And again, there's a nice Debian URL there about subkeys and how they work. So how do we install this? I'm going to install GNU PG2. And that it's not Postgres PG, it's GNU PG, right? It's GPG. I'm also going to install something called SC Daemon, which is called a smart card daemon, which is required for this. And if I now look, this is kind of like blow your mind, but if I now run GPG2, I actually can see inside of my card, my PIV card, okay? And you can see the version, you can see it's a Yubikey. I can set my name, my sex, my language, my URL of my public key. That's a nice thing, okay? And even there at the bottom, you can see the different keys that I have. The signature key, the encryption key, and the authentication key, okay? In this case, they're empty, but we can actually fill them out. So I'm not going to go through that, but you get the idea. There also is a Gpgd agent that I wrote. Again, feel free to use it if you're familiar with it. make sure you check it out, test it. There's no warranty, but it was just something I found useful to get it to start and to get it to manage that daemon, which is always running, because by definition it was kind of hard for me. Okay. So now if I run the Gpg Agent D, I can actually reset the Gbg Card. And that's actually using that URL there at the bottom. This is literally what you have to do to reset the card. And then I can configure the card via GPG. I effectively make a directory called Yubikey. And I delete the key in there. And then I generate a random pin for the key. And I then echo the pin into a file called Open Pgp.pin, and then I can actually run PGP, change the pin, and it automatically will kind of set it for me. Okay. Now, if I want to go and I want to set my various pins, I can loop through, set what's called a puck, which is there's a pin and a puck. The pin is what you use when you're just running it, and the puck is basically an administrative key that you use when you reset it. So I'm going to set that as well, and then we also have an admin that we'll set at the same time. So we have a bunch of random numbers. There's an admin pin that we're gonna set as well. Okay. This is a little better visual, I think, of what's going on with the key creation process. Again, when you put the crypto hardware in, it's empty, right? So you have to generate the keys and get them onto the device before you can use them, right? So effectively what we have here is there's two parts of the key. Again, there's a public part and a secret part, private part, if you want to call it that. We have a master key, and we have a signing key, an encryption key, an authentication key. The Yubikey 4 has only 3 of those, which works just fine. So we set the master key, then we set the sub keys, and then we effectively copy the private key to a USB device. Because if I don't do that, I don't have a backup. Because remember, if you do it on the card, you can't get the private part back out. So I recommended generating it on the computer, maybe on a USB device, and then copying it over to the Yubikey, and then removing the USB device and storing that in a safe somewhere, so you have a backup. Okay, and that's kind of what I'm doing here. So I'm going to do a Gpgd key gen. So it's actually going to generate the key that I want for the particular slot that I'm interested in. Okay. And that's actually what I'm doing here. Again, another URL. I can set my name, my email address. I can put a comment in there. So it's kind of like interactive. You can kind of go through it. Then I can edit the key if I want. Now you can see the 2 keys right here that are now in the Yubikey in my case. The E stands for encryption. So that's my encryption key right there. Okay. Then I can add another key. Here I'm going to add an RSA key, and I'm going to say sign encrypt. So I'm going to pick E for encrypt capability, and then I'm going to do sign, and I'm going to run through it, and basically it's going to run through and going to create my keys for me. So these are the codes that Gbg. The A is authenticate, C certificate creation, E encrypt, and S sign, and then your public, your secret keys, your sub keys, and your public keys is the way it displays it to you. Because when you look at the key itself, you can see there on the left we have pub and sub, and then at the bottom we have SEC and SSB, and then on the right you can see the sign for S and the E for encrypt and the SC for the other. Okay, so again, it's pretty complicated. That's the way PIV devices work, and GPG allows you to access the Yubikey as a PIV device. If you want to do authentication, you can basically do that. You can see that you can effectively create those keys, authentication key, and then we run through it. And now you see there is actually an authentication key stored here, right up here at the top. And then we're going to go through the same thing. You can now see authentication key is filled out, right? And now we're going to back up the keys. So I'm going to copy them over to a USB device so that I have them, right? And I'm going to pull it out and put it in a bank somewhere or in a safe. And then you can actually see that we have our keys all kind of ready to use. Okay. You can delete keys. This is how we're deleting them. Delete secret keys. And we can even import the secret keys in. And again, we have the wiki makes it a lot easier to use. Okay. We can move the secret key to the card. So again, we generated them separately, and now we're going to key to card is the command. So it basically takes the key that's in the file system and puts it on the card. So I'm going to put it in 2, which is the encryption key slot. And now I have, you can see an encryption key defined for in this card. Okay. And I can toggle between different keys, key 0, and it shows me key 0. If I go to see key 2, it shows me key 2. Notice how the star kind of moves around, that little star there kind of moves around for you. Okay. Key to card, again, this copies a file, a private and public key from your file system into your card. Here I'm going to do the signature key, and now the signature key has been loaded, as you can see. And I'm going to do the final. And now you can see all 3 slots are full. Okay? So all 3 slots now have keys in them. I remember I said there's 3 different slots in a Yubikey that you can use. And that's exactly what's going on here. Okay? And yeah, it's this like little syntax stuff of how it displays. It's kind of cool. Okay. Any questions of configuring? Yes, sir. Yeah, it might. I don't remember. It might delete at the same time. I know I have to back it up first. So I backed it up first, and then, yeah, a key to card kind of wants it out of the file system. Now, because it's a little tricky, because for me, I would not normally store it on the file system. I would store it, I would actually do all my work on a USB device instead of doing it in the file system, because the file system gets flushed to disk. Even if I delete the file, it's kind of still there potentially. So I would do it everything on a USB key. But if you do that, then make sure you don't copy it to the Yubikey and have only one copy, because then it's gone, right? So I would almost like create a separate directory and just copy them all in there, and then do key to card while you're in that directory, and then just flush out that directory, right? So just a little, I wish this was simpler. That's what kind of got me. Like, there's a lot going on here that you have to understand to really make use of this stuff. It's not a plug and play in any sense of the word, at least to me, unless I'm missing something. Okay, yes, sir.
So what happens to your public key on the device? How do you, I guess my question is, if you want to change your private key, delete it off the device, how do you get it back to, you want to create another private key? Do you have to remove the public key, the initial public key off of the device? How do you start from scratch?
Sure. So the question is, how would you recycle or change the keys at some point, right? So the public key you can pull off the device at any time, because it's public, right? In fact, the earlier slides showed you an example of me pulling the public key off, right? Of the Yubikey when we were at OpenSSL. Remember, I just yanked it right off the device, no problem. That's the private key you can't get at, right? So effectively, you can't. The only thing you can do is to overwrite the private key on the device. Okay, so it gets a little tricky, because if you're using it for encryption, for example, okay, and you're encrypting stuff, and then all of a sudden you decide, I'm going to change my encryption key, right? Well, we only store one encryption key on the Yubikey and all the PIV devices, not the Yubikey specific thing. So what if you have something and you're encrypted and you just lost the private key, right? So what you almost have to do if you want to rotate keys like that is you almost have to decrypt all your data, right? Change your private key, and then re-encrypt all your data back with the new key. And that's somewhat disappointing. Maybe you just buy a second Yubikey and you keep the first one around, right? Or at least you're going to keep that backup in the bank around maybe forever. Like maybe you're just going to buy 10 USB sticks and you're going to put dates on them and they're just going to sit in the safety deposit box or the safe, right? Because you can never know you've gotten all of them when you come back. So you can't, it has slots. We got 3 slots here. Technically, you could use slot 1 and slot 2 and slot 3 for encryption if you forced it to. I don't recommend it, but you can. You wouldn't be able to sign anything probably, and you wouldn't be able to authenticate using it, but you could potentially use those all for the same purpose. Then you could get 3 of them in there, but it still becomes like a mess, right? So I think that's a problem. I don't really know what to tell you except, yeah, I think the good news is that this stuff is so secure and so non-brute forceable that you're probably not going to be rotating your keys every month or maybe even every year. It may be a 5-year, 10-year thing that you're going to be rotating these things. Because remember, if you're holding the Yubikey and the copy is never left the safe, then nobody's been able to get that out of there. It's not like a USB stick, somebody making a copy and you don't know it, right? There's literally no way for even the manufacturer, I think, without using electron microscope to try and read the storage on it's just almost impossible. So that's, I think, a different scope of risk that we're used to. That's why we rotate passwords, because they get, who knows where they go, right? They get passed over the network, they get written down, they get, these are not issues with a hardware token, and that's why I got kind of excited about them. That answer your question? Yes, sir.
What would be a good method to mass deploy this?
I'm sorry?
What would be a good method to mass deploy these Yubikey?
What would be a good method to mass deploy these keys? Well, the real trick would be to automate the config of these things, right? Sort of what I've done, and then you would just hand people a key. They wouldn't know you have a backup. They wouldn't know what slots are. They wouldn't know anything. It would basically be a pre-configured. I would never give an end user this. It's just like, don't even go there, right? I did it because I'm crazy, right? But a normal person you'd have, and the beauty of the thing is once they have it, if they don't lose it, and even if they do lose it, the person has to guess the PIN. I haven't even talked about this. You only get like 5 guesses at the PIN. And if you fail 5 times, the device is literally locked. You can't get in again, period, right? Now there's an administrative PIN which will allow you to unlock it, but you can only try that one, I think, 10 times, and then that'll lock up. So you almost have to assume that if this thing's compromised, it's gone. Nobody can read it. You have a backup. You make a new key. The other one is just dead. And hopefully you have it. If you don't have it, I don't know. I guess maybe you make a new one. I don't know. But that's the interesting part. The physical thing is very important here. And if you configure it, yeah, it just runs. Once you configure it, they run normally. You just stick it in and you SSH and you're in. Like there's no, that's how Google does it. All these big, a lot of organizations, the Gemalto and Nitro, all these organizations are using it for mass deployment. Everything's pre-configured. All their SSH is configured. All their config files are configured on every laptop. And you just stick it in, you're in, pull it out, nobody's going in. Yes, sir. So the question is a Yubikey and a PIV device, or a credit card and a PIV are the same? So yeah, you have a great point. So the traditional use of a PIV device is a credit card. It has the person's picture on it. It's government. Any government ID is going to be a PIV device. So it has a person's picture and a bunch of stats about them, and then a little chip. Okay, that is the way the government has basically implemented PIV from for a decade or two, right? What we see now in the past 7-8 years is that PIV device, they're disconnecting the card from the chip. And now, instead of having the traditional way is you have a PIV reader, and you stick the card into the reader. You see them in movies, right? The guy puts a thing in, and that's how it works. It actually checks the authorization slot on the PIV, and it finds out who it is and validates their name. That's why you have a name slot in there, the whole thing, right? What we've seen with the Yubikey and the Nitro and so forth is now taking that credit card and shrinking it down. We don't need a credit card anymore. We don't need a reader anymore. We just need a USB slot, right? So there is a Yubikey PIV device that's literally the size of the chip itself that's on your credit card, okay? And then there's also some that are bigger, like more of a memory stick with a little stick on the end. There's one that sits in your cell phone in the USB-C slot. You just stick it in the slot, and then it functions as a PIV device. So you're starting to see more form factors. It's a little different, and the picture's not on it, but it's obviously more functional because now we have a direct USB interface to PIV devices that we didn't used to have before. We used to have a card. The card would have to go in the reader would have to be connected to the computer, and that's the way the government systems work. You have a terminal, you have a PIV reader, you stick it in, and that's how you authorize yourself on that device. Did that answer the question? Yeah. So the attributes that I showed, are they specific? Okay, so the attributes that I showed are, I believe, so you're asking about the attributes like SCC and stuff like that. So some of this stuff is standard, like all these fields, these are standard part of PIV cards right here. This is all standard PIV. All PIV cards have all these fields, I believe. The difference is that this appearance, this is all PGP. This is all very specific to PGP. And in fact, I even mentioned that it changes in another release and stuff. So this is how they're displaying. They have to map the left-hand side, the right-hand side. And that's how they're doing it. Yeah, sure. Other questions? Yep, sir. So why would you use Yubikey key generation? Because you don't have a backup? Is that what you're saying?
I'm asking, like, you're doing generation on an insecure device.
That's right. That's right. Right. That's correct. So why would you do it? So the question is, the reason I'm generating it separately is so I can make a copy and back it up, right? That's why I'm not doing it on the Yubikey. Why would you want to do it on the Yubikey? You may not care about a backup. You may basically say, if I lose this, then my authentication is no good, and I'm going to have to get a new authentication. Somebody's going to have to give me a new key. Nope, nothing wrong with that, right? I gave the longer one because if I'm doing encryption and I encrypt something, I want to be able to decrypt it later. But for authorization, if you lose the device, you just go to the administrator side, I need another Yubikey. They're like, okay, we'll invalidate the old one and we'll add the new one and we're done. Right? So again, depending on whether you need that backup would determine whether you do it on the Yubikey or not. Much easier to do it on the Yubikey, no question, right? Because you just issue a command and it'll fill in all those slots, no problem. Right? Good. Yes, sir.
Just want to point out, since we are at a Linux open source conference, UPG, open source, key generation algorithm on your Yubikey. I don't want to talk about Yubikey, but I'm just going to say, you don't have the source code, you don't know how specific the mouse key generation. Yubikey has a full multiple but you can't look at the source code. And like your UPGs, same quality as the cells. Well, you can't see the UPG source code. You're trusting that their algorithm doesn't have holes. I don't know about you, I'm not qualified to.
Are there any hardware devices that have open source code for that guy? Yes. The Nitro is open. That's great. Good. I learned something today. All right. So the Nitro has its source code open. That's kind of cool. Yeah. Great point. Yes, sir.
What is the acronym for PIV?
PIV is verifier. Yeah. Yeah. Personal identity verifier, I think. Yeah. Yep. Other questions? Good questions, by the way. Yes, sir.
All the slides show
So the question is, yeah, so the question is what different encryption, public key encryption methods are possible with these devices. Basically, Yubikey supports a couple of them. I don't know what the Nitro supports or Gemalto, but effectively, these devices could support any, any public-private key specification. It can be anything. Right now, it's that, but there's nothing hardwired to the specification that indicates what it has to be. Okay, yes, sir. Ma'am, I'm sorry, sir.
Do you know if the Yubikey supports the
Does the Yubikey support elliptic curve public keys? I don't remember. I'm sorry, I don't remember. I don't think so. That's a great question, though. I wish I knew the answer. Other questions? Okay, all right. Let's actually run. Let me just show you the use of this key so you can kind of see it. So here I'm using the word test, and I'm piping it into GPG. I'm asking it to encrypt with Armor. I'm giving the recipient ID, and then I'm decrypting at the same time. So I'm actually going in, encrypting it, and then decrypting it. And you can see test goes in, and test comes out, right? If I want to sign something, I can use a clear sign, and you can see it comes out in the same way. Okay, so that's an example of using Yubikey to sign and unsign something. You can use Open Pgp with OpenSSH. So remember I showed you OpenSSH using it with the standard traditional. You can have OpenSSH use Open Pgp. So here we have a normal SSH that's failing. I can do an SSH add with the public key of the Yubikey, of Gbg. There's my setting, and then I can actually concatenate that on, and then all of a sudden SSH will use the OpenPGP key instead of the PIV key, depending on how we want to do it. Okay. This is a very complicated slide. I'm not going to go into it. It's basically the software stack for these public devices. And it is not pretty, right? You got OpenSC tool, PKCS11 tool, PKCS15, and then over on the right, you have the internals of the Yubikey, both the PIV part and the OpenGPG part. There's actually two parts inside the Yubikey. One's the PIV, which is what the gentleman asked for, and then there's another part which is OpenPGP, and then there's another part which is just for authentication. So, not fun. PIV versus OpenPGP, this is kind of just an informative slide. Which one should you use? PIV stores all user information on removable media. OpenPGP really was kind of designed for storing the keys in the file system. So you're kind of copying over. What's interesting is that a PIV has the public and private all on the separate device. So it's made to be removed and added. For PGP, it really kind of expects the public part to be in the file system. So it's not really thinking of you inserting and removing and coming in as a new user in the same way. So you may want to favor one over the other depending on what type of system you're using. Okay, and again, application support. Okay, let's talk a little bit about the Postgres side. And again, this is going to be super complicated, but if you were in my talk on Friday, where I talked about, actually, if you were in Jim Mulginski's talk anyone here in Jim Mulginski's talk on Friday morning? Right, we have two. He gave my talk. It's this slide. So he actually ended up using my slides for his talk. And here the concept is that to do Postgres, you have the encryption key removable like a PIV device, okay? And you're effectively encrypting and decrypting on the client before you send back and forth on the network. Okay. You could also do that with symmetric keys, but it's not as secure. Here's an example of this. Basically, I'm creating a user key, and this is a whole bunch of PSQL, which I don't expect you to understand. But the idea is that we generate some random numbers, we put in a variable, we actually store that into RSA util, so we can kind of find out what's going on. We put that in another variable, and then we can actually, from the Yubikey, use either decrypt it, encrypt it by sending the keys across, or we can actually do the encryption on the client. So again, I'm not sure how you want to do it. This is a lot of stuff here. But the goal, like for example, this particular slide is showing that when you remove the Yubikey, nothing happens. You get an error, right? It's basically saying, I can't issue this query anymore because I don't have the key anymore because I removed it. That's what you want to prove, right? If you're going to test it, pull the thing out. Does it still work? It better not. This is the goal, right? Here's a more sophisticated example, again, way beyond what we want to sort of cover here, but Postgres has encryption. There's some libraries we can use to encrypt stuff. There's even a PG get key that I used to allow you to send keys back and forth. I'm not going to go into this, but again, you can actually use the hardware security module on the server, on the database server. You plug it in, it operates. As soon as you pull it out, nobody can read the data anymore, right? That's what we want. Kind of cool. Questions? Yes, sir. So how do you handle cases where the key has to be, the device is moving around and you're not sure where to put it, or yeah, so you're moving between VM hosts. The only real good way of doing that is to make duplicate hardware keys and put them on each device, right? And again, if you're generating the key externally, you can do that because you just put a new key in and you go through the same process again, and now you have two keys that are identical, and they'll function. But then, obviously, if you remove them, you want to remove both of them so that nobody can use the other one while you're, yeah. Good. Yes, ma'am.
Can you go back to the previous slide? Can you explain a little bit more about the remote SM? I'm not familiar with
So, yeah, so in this case, this is basically a special utility I wrote called PG Key, which will pull the key off of an HSM or a Yubikey or something like that. So yeah, it's very specific to Postgres, so I didn't really want to cover it here. But again, you can set up keys for functions, and yeah, this gets just like super, super complicated. You can use it for transparent encryption if you want that feature. And again, I'm just running through. Here's a case where we actually have a trigger on a function, and we pull the key off of the Yubikey or the hardware security module, encrypt it, and then continue. So we can actually by looking at the bottom, every time somebody does an insert or an update, we automatically encrypt it with the key that we got, right? Again, this is very databasey, so we're not going to cover it, but if you want to go into this, feel free to do that. Okay, here's a transparent insert, right? I just inserted the word test, which is up here on the top line, and you can see when I do a select from the view, which decrypts it, I get the right data, but if I go to the raw data, you can see it's encrypted, right? Right, so this is me inserting test. This is me running through the trigger. This is me just looking at the raw data. And again, as soon as that key's out, the view won't work either, which is the whole goal of what we're doing here, right? Same thing with update, same thing with delete, right? And again, yeah, update. So some performance issues here of how fast it is. Indexing issues. Data key expiration. So the idea of having to rotate the key every so often, very difficult to do. Again, very databasey. I don't want to kind of go too much into this. But you can basically encrypt your data, or you can encrypt your keys, and this is some of the ways you can do encryption inside a database. This is not a database talk for this audience, but I just wanted to kind of, I'll just go through the slides. So again, it's like, where do you want to store? One of the primary reasons I got excited about this is, if you're doing encryption on database, where are you going to put the key, right? Are you going to put it unencrypted in the file system, which some people do? Are you going to encrypt it in the file system and then require a password to decrypt it? Or what we're doing here is encrypting it and requiring a Piv device or a PIN to decrypt it. And I think that's the real final thing I wanted to get across. I'm not saying you have to do it, but I'm saying this is how people do it. if they want that level of security. Okay. And again, how do you want to store it? It's also called a CAC card. If you've ever heard of CAC, that's the more familiar term. And it's called a CAC card, but it's really common access card. So it's common access card. So you get the idea. It should be just a CAC. But again, you have a CAC option, you have a Yubikey option, you have a USB option, hardware security module option, or just external option. Again, we have a nice, very hefty URLs here at the bottom about these details. Okay. All right. So thanks very much. I'll take some questions. I know I'm a little bit over, but I don't want to lose that opportunity. Yes, sir.
For Max update, what is administrative to invalidate the key? How does that work? If somebody lost, you had 100 keys and somebody lost a key, what actually is an invalidated process to invalidate the key?
So how would you invalidate a key that was lost?
To invalidate the key. You talked about invalidating a key that was lost.
How do you invalidate a key? What's the process, right? So you really have, so how do you invalidate a key? You really have two options. You can either create a new key from your backup and don't invalidate it at all, right? With the assumption that even if it's stolen, nobody can read it because they can only get a couple tries at the pin. Right. Well, all right. So if you want to, so basically if it's for authentication, then all you really are going to do is to just issue a new key and invalidate the old one, because it's just like a new password, right? So it's if it's for SSH logins, just remove the old line, you put a new line in, you're done, right? If you're encrypting data, then you're probably going to need to go to your backup, decrypt all the data using your backup, right? And then create a new key and re-encrypt it using the new key, and then that's your new key. Yeah. The interesting, for authentication, there's no lifetime to the authentication. You're authenticated today, and tomorrow you do it with someone else, right? With data storage, then you have a lifetime of that key now, and you have to expire that key by really removing its use and then making a new one. Other questions? Yeah.
I'm having used Postgres for about 7 years.
Mm-hmm.
So can you walk me through, I'm especially interested when I have to historical backup in terms of security encryption that.
Sure.
Quickly walk through that, because I don't think 7 years ago that.
Right. So I'm going to take that offline. If you want to come up, I'd be glad to answer that. Yes, sir. So with indexing, I would be happy to cover that as well if you come on up. So I'm a little over, so I don't want to go into any Postgres specific questions right now. So thanks. But yeah, come on up and I'll be glad to answer it. Anything else? We're good? Well, thank you very much. Appreciate you sticking for the last one. Thank you.